So this problem is asking us to compare these two functions, r of x and q of x. We're trying to find out which one has the smallest minimum value. For r of x, that's quite easy to tell. When we're looking at r of x, we can see the minimum occurs here when r of x equals negative 16, where x has a value of negative 2. So now what we need to do is figure out what is the minimum of q of x. That one's a little bit trickier because it's given just as an equation in standard form. So there are a couple different methods we can do here. One method is to complete the square, and by doing that, we're going to rewrite it into vertex form. So to do that, we need to both add and subtract half of our b value squared. So our b value here is positive 2. So we're going to take half of that, which is 1, square it would still be 1. So then we're going to add 1, but then we're also going to subtract it, so we're not actually changing the equation. And notice I'm just keeping that minus 8 there at the end. Okay, so the benefit of that is that now this x squared plus 2x plus 1 is a perfect square. So we can write that as x plus 1 all squared. And then this negative 1 minus 8 can be simplified to negative 9 or minus 9. Okay, so just like that, we've figured out the coordinates of our vertex because our h value here and our k value here tells us our x and y coordinates of the vertex. So our vertex is negative 1, negative 9. Okay, so that means the minimum is at negative 9, which is obviously not as small as negative 16. So the solution here is that r of x has the smallest minimum value of negative 16. And by the way, if you're curious, I did mention that there was another method you could do here to find the coordinates of the vertex of q of x. And to do that, there's actually a formula to find the x coordinate of the vertex. And that formula is negative b over 2a. So our b value is positive 2. So this is negative 2 over 2 times a, and our a value is just 1. So negative 2 over 2, which simplifies to negative 1. So you can see that matches the x coordinate of the vertex. And from there, you could actually plug in the x value of negative 1 into q of x, and then you would get an answer or a solution of negative 9. So a couple different methods to do it. I just wanted to show you that there are both ways. All right, that's all for this video, and thanks for visiting JD's Preparation.